Hello, thank you for watching this presentation about learning from work breakdown structure diversity. Our team is called In It for the Experience. 7 of us contributed to this project, and this is us. We all work for different companies in a range of sectors. 5 of us are data analyst apprentices with projecting success. This is the full challenge summary that our team was provided with. In order to support the roadmap, this challenge asks how we can improve project outcomes using work breakdown structures and to understand their diversity. Our team aimed to build a machine-generated structure using previous data. Our scenario's use case is a new 12-story building with special features.
We were given a dataset containing 3-tiered work breakdown structures for 9 sample buildings. The data required some initial cleaning to populate missing information, collate information from our sample buildings, and create a WBS library for future reference. Our clean dataset still required modelling prior to using our solution. For example, we needed to model our data to obtain missing Tier 2 descriptors for our tool's usability. We created keywords for use in our model, recognising a manual process would not be feasible on real-world larger datasets. To add future resilience, we tested an automated text classification API to cluster keywords taken from the Tier 3 descriptors. Whilst the list isn't perfect, it could be improved using Python and machine learning.
As a team, we worked together to use clean data to create a code that would allow us to incorporate user decisions into our data model and subsequently produce a work breakdown structure unique to that specific project. The chatbot asks questions around things such as number of stories the building has and types of cladding. This information can then be used to determine the base work breakdown structure. The decision tree is a visual example of how our bot identifies this. After the building type is identified, using the bot, we can then gain further information around any identifiers that are more unique to that project, such as a spa, a car park, and so on. This allows us to add elements to our base form to form a unique output. Final output is a unique work breakdown structure based on specific criteria requested through the chatbot. Python takes the work breakdown structure library along with the directory of building type work breakdown structures to draw out relevant lines. For example, if the chat identifies that we need base building type 1 due to needing a multi-storey building with a steel and concrete frame and cladding, and in addition the user identifies that they would require a spa, then the code searches the direct building types for building type 1 lines and searches the work breakdown structure library for level 2 and level 3 lines that mention the word spa to be included in the model. The 2 elements of data, the base and the special requirements, will then be combined to produce an overall work breakdown structure for the project. Here you can see an example output. This work breakdown structure is reflective of a multi-storey building with a steel and concrete frame, cladding, and 2 specialty features or keywords, a spa and car.
To visualize this output, we bring it into Power BI and into a tree map. We then dynamically can slice the data to not only show the custom output from the Python file, but also show different buildings based on data that already exists within our data set.
To ensure the requirements are captured and traced through to the end solution, these are listed out along with the underpinning pain points and the features of the solution. This enables the golden thread to be drawn from start to finish and provides, in essence, a high-level requirements traceability matrix. In large, these requirements have been met, however, certain aspects could not be met in full by the technical solution, and this is indicated on the diagram by the dotted line.
Some of the limitations to this challenge was the complex Python coding that was required to extract the data from a chatbot. There wasn't enough data originally to create a fully functioning model. We would be looking at requiring around 90 building WBSs. Next slide. What does the future look like? A more friendly user face to encourage people to want to use it rather than have to use it. Utilize machine learning to scale up the tree to larger data sets. Utilize correlations derived from past projects to prompt and create complete WBSs. Link Python to Power BI for visualizations and dynamic way of clicking through the options. This solution uses Python as a chatbot. It would be more user-friendly to develop a pop-out chatbot which hides the code in the background. And this leads us on to the judges' questions. So the first question was, how adaptable is the code or solution to the WBS? It currently fits the scope of the data provided, but more data is needed to broaden the application.
Question 2. Planning is more often than not a tedious iterative process with involvement from a number of stakeholders, so this tool has the potential to improve efficiency in the initial planning stages by leveraging past experience to create a WBS that can be used as a basis for subsequent refinement with the project team. Likewise, during project execution, if a change request is received, the planning or project team can use this tool to quickly generate a revised WBS, which could be used to support a what-if scenario or the input into a detailed scheduled development.
The final question asks about skills of the target audience. Making the user interface more accessible will certainly be advantageous, such as through speech recognition. With additional work and time, it may also be possible to create a true chatbot which hides the coding language in the background without compromising its functionality. Thank you very much for listening.